So, welcome to my talk. Let's see what we have here. I have only some slides because most of the things will be a demo. Hopefully the demo gods will be on my side. So first, who I am, then what we want to do today, and then how we want to do it. So first for me, I'm Robert, as Pelram already said. I'm working for BetaDots. I'm doing Puppet since around 2011, and Icinga since year 3 or something. And I do monitoring because nobody else does, because on most projects, they start, they do stuff, they go live, and then, oh, we need something like monitoring. And I love to do monitoring, but I also love to do being lazy. So I use Puppet a lot because I don't want to do things, let Puppet do things. And if you're interested in the slides in the code from today, it will be in my GitHub space. There will be a link in the slides, and then we can see you can use the profiles, the code I use to do this demo here. Precondition for this talk is that you have a working Puppet environment, so you have a Puppet server running, and nodes can connect to it. So, what are we going to do now? We have a fresh, clean Puppet environment, and I will spawn a Icinga node, so for the Icinga main server. And then we will install the main server with its database, the IDO database in this case. I know there's the Icinga DB, but I did not start yet with it. And then we will go on to install the Icinga Web 2, so that we have a nice web interface. And at the end, we want to add some configuration and some nodes to the Icinga server so that we have something to view in our nice GUI. I will use 3 of the 4 existing Puppet modules for this. I will use the Icinga repo module, the Icinga 2 module, and the Icinga Web 2 module. The Icinga DB module also exists, but I didn't touch it yet. But I will in the future. So then, let's see, time for demo. Let's wrap up Vagrant up Puppet, start our Puppet server. And in the meantime, yes, when it will be important, I will increase the font size. But at the moment, I'm just starting some Vagrant boxes. And then I will increase. I will go over here. Is this big enough to see that I have some code here and I have a shell down here? Is the font big enough? Yes. Okay, so we start with a clean environment. So as you may know how a control module works, there are some profiles in there or not. I have a base profile which does nothing. I don't have Icinga, I don't have anything. I prepared something. Let's see if my Vagrant boxes are up and running. Okay, Icinga is still starting up. Puppet server is there. So, okay, now they are ready. So, first things first, we need a Icinga server. For this one, I go to my another branch so that I don't have to write all the things. And so, now we see we have a monitoring server class. How can I do this big? Let's do it like this, and so. For the main class, I am using the Icinga repos module, as I taught already. I'm using the MySQL server class, so that I have a backend for my IDO database, and I'm using the Icinga 2 module. Then I'm looking if I'm on Debian or Red Hat, and deciding if I want to install the monitoring plugins, or as it's called in Red Hat environment, the Nagios plugins all. And for some other strange reason, on the Debian systems, the Icinga user is still called Nagios, and on the Red Hat environment, it's already called Icinga. So these are some pre-assumptions. And then I'm going to manage my zones, because I have a main zone for my main server, and I may have a global zone for all my configuration data, and there I want to manage this. I'm doing this recurse, purge, and force, so whoever puts something in there which is not managed by Puppet, it will get deleted. So that there are only is configuration I put there with my automation. So then I'm loading the zones from my Hiera data. I will show this in a moment. and then I will load all the Icinga objects. And at the end, I'm working with exported resources, because I don't like to click in some strange UIs, and I don't want to click my admins in UIs. So I am importing all the endpoints, hosts, and zones from Icinga over the PuppetDB, and therefore are these three collectors here. So I need some data for my class. So first I'm loading my class, and I'm loading the standard zip from Puppet Labs. Then I'm setting some database settings, so I want to have a strong root password, for example, and I want to have an IDO database. This is down here. And then I want to have configured my Icinga server. I want to load some features. I want to have my main instance named. And I don't want to use, for example, the confd configuration, which is deployed by the package automatically. And therefore, it's a switch, so that I don't want to use that. Later on, I have here my zones, as I talked before. I have my main zone and my global zone. Main zone is for the main server and all the agents, and the global zone is for all the configuration, which will be spread upon all nodes. Then here you can see I'm having the Icinga server objects. The first object is the API user, because later on we want to use the Icinga Web 2, and this has to talk to the Icinga core somehow, and it will do this via the API. And then I have a generic host template for hosts, and I will declare my Icinga main server as a hard-coded host, because this one doesn't export itself and collects itself again. I declare it directly. And then I have a service template and some user groups, standard data, which also is all in the confd configuration, but I moved this all over to Hiera, so that I don't have to get to know these files. I have a generic user template. I have the generic Icinga admin, so that I can log in to the web interface. And then I have some defaults, like in the Icinga Puppet module, you can declare for each object a target, so a target file where the object should be written into, and so that I don't have to declare this every time. I have some defaults and default targets, so that API users go in apiusers.conf, hosts go in host.conf, and so on. So these are 148 lines of Hiera code. So let's see how this works. We stay here in these yes, here, I want to go background, SSA, space, SSH. If you have some questions, ask because I think we have some time to wait. Icinga. So, big enough. So with this data, I'm now running Puppet on the Icinga main server, so that we can get our installation. Loading some facts, connecting to the Puppet agent. Oh, this is not supposed to happen. One moment, what is happening here? Okay, demo is not working. Let me see why. Yeah, this is not, classes are loaded, but why is there not happening anything? Yeah, just try again. I prepared a workbench box, maybe I have to do something more here. We try to start with the Icinga box again. Let's look at the Puppet server if there's something happening there. This is when you do a demo, you prepare the demo, and then you do the demo, and everything is strange somehow. Let me just clean up on the Puppet server, and then, so now this. So, okay. Icinga is starting up again. The vagrant box is starting, installing the Puppet agent. I think I'm out of time. So now the agent, because I respawned the machine, is getting a new certificate, doing plug-in sync with the Puppet server. And then I hope this demo works now. Let's see. Yes, now it works. We see now the MySQL server gets installed, and there's a apt thing running for the Icinga stable release. And then I think after that, the Icinga core will be installed, and then we have a running Icinga server. Didn't know what's happening here. I tried to prepare. Maybe I did a bit too much. I have 3 screens to look on. Can you stop all your downloads? I need the bandwidth. I checked in before. There was like 140 megabits available. Now it's going forward. Oh, it was downloading the MySQL server. Okay, any questions until yet? So while we wait, we can talk about. Over there. Micro is coming.
Hi. When you build this Icinga master via the module, you'll get a new CA certificate, and it's going to take ownership of all the certificates via the module for satellites, blah, 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 blah. So do you get that certificate to Hiera data back or something like that, or how do you keep track of it?
The certificates I'm running on the Puppet CA. So I'm using the existing Puppet CA, which is also on the client, and I'm reusing the certificate so that I don't have to do my own Icinga CA.
Okay, thank you. So Puppet DB is actually your CA for the whole environment. Puppet itself, the Puppet CA.
I didn't understand this.
Puppet CA becomes your CA authority for all Icinga infrastructure. Is that correct? Okay, thank you.
Because the Icinga module has a field for this one. When we look at the data again, there is a small snippet. Where it states Icinga 2 feature API PKI, and there you can say which PKI you want to use. In this case, I'm using Puppet because then I don't have to care about. Yes, this may be a security issue if someone breaks my Puppet CA, although Icinga is broken. But for simplicity, I'm writing on the back of the Puppet CA here. So, as we can see, our demo first step has finished. We have now, when we look etc, Icinga, we have a Icinga config somewhere lying around. We have system ctl status Icinga 2 running, and we can do Icinga. No, don't get me. We have Icinga object list working. So okay, our core is now up and ready. We have open port. Like for the standard, we have opened the port 5665. And now, yeah, we have a core, but maybe we want to have a web interface. So therefore, I'm switching to another branch. Git switch. And I think you have seen by now my title was a clickbait. I'm over 50 minutes at the moment. So let's go to this. Do I have something to drink here? No, I don't. Can I have a bottle of water or something? So, now I have another class for the Icinga web. I called it web, and I'm also including here the repos class, the Icinga web 2 class, and I want to have the Icinga web 2 module monitoring enabled so that I have a view of my monitoring stuff going on. And in the Icinga YAML, the data, I have now a part in my Icinga YAML for the Icinga web, where I specify which database backend to use, and where the IDO database is, and which command transport I want to use. I want to use the API here, as I mentioned before. I have the root user, and I have to use this. So let's see if we can have a working web interface. Wrong shell, right shell. When I typed correctly. Thank you. So with the Icinga Web 2 module, you can configure the base Icinga Web 2 interface, and you can configure modules like the monitoring module, the director, or any of the other modules you heard in before at the start from Bernd. Most of the main modules have some classes in the Icinga Web 2, so you can directly configure them from Hiera and Puppet. So now the database is prepared, and in the back it's downloading Apache at the moment so that we can have a web interface. Do we have questions while we wait? I have some time to talk. Do you want to see some of the classes again, or there is already going on. So, and it's ready. Because Apache was, there's something of a dependency problem because Apache was installed before the Icinga Web 2 code was deployed. There's some inconvenience, and I have to reload Apache again. This is not part of the code yet. Start Apache 2. And now when I go to my slides, there I have my. So now I'm on my local Waken box with the local IP. I can log in with Icinga admin and a super secret password Icinga. And you see, or maybe you don't see because it's too small. I have a running web interface with one host in there. It's the Icinga main server, but it has no services. That's some kind of inconvenience. Let's add some services. No, where's code? Here's code. Git switch Icinga checks. Now I added some checks to my YAML. We have here the services part, and you see we have a service template, as I showed before, but now we have real services like for disk, for the Icinga service running, for load, and for procs, and swap and uses. So there's some basic checks which come all from the monitoring plugins or Nagios plugins all. and are pre-configured in the backend from Icinga, so that I directly can use them without declaring the check command. So let's run this on the server. So I could have done this in one row, but then I couldn't have shown you all the small steps to getting there. So we see we have now in the global zone a services conf deployed with the services. Let's have a look. Here we have in Icinga language some apply services for the disk, for Icinga, for load, for procs, swap, and so on, like I did declare in the Hiera YAML. When we now go to our web interface, we see, oh, there are some services coming online. They are being checked one after another. So now I have services. Nice. So I can configure now services directly from my Hiera backend over Puppet on the Icinga main server. So with only the main server, it may be a little bit lonely here, and I will add a node here. The critical is I want to have the critical here because then we can see it's real doing something. I have no swap on the machine, so it tries to find swap, but that's not possible. So how do we do at agents? I talked about using exported resources. Then let's have a look how this could look like. Git switch agent. So now I have some more code here. I have, for example, the agent class, which will get all my agents in their role or in their base profile loaded. So I load Icinga 2, I load feature API, feature checker, and feature main log. And then I have another class because sometimes I want to have Icinga host objects from nodes which don't run the Icinga core as an agent. Because maybe you have some fancy, well-aged Solaris instances, and there is no Icinga agent for this one, except you compile one for them. And so I want to have exported hosts where I declare a Icinga host object and export it to the PuppetDB. And if I set the flag, that will also export an endpoint and a zone for this host. So you can only export zone and endpoint if you have an agent, otherwise this makes no sense. So there's a flag for that. So now we can export host objects and endpoints and zones into the PuppetDB and then collect it again on the Puppet main server. As you see, we have these objects here. These are virtual objects. They are not applied on the server directly. They are just filled out with all the variables and then exported directly to the PuppetDB. And as you have seen in the server, here are these spaceship operators. And these are the three collectors which will collect from the PuppetDB again the exported resources. So, I need an agent. So, vagrant up agent 1. So I'm using another host for this setup. Just starting up the Vagrant box. In the meanwhile, I can show the data which I need for the host. I'm importing the class agent and the class exported so that it will install the agent and export its host objects and its endpoint and its zone. And the comments I will show you in a moment for which they are. So we are ready now. We need to go here. No. This is our agent 1. And one Puppet again. Puppet agent -t. It's already running. Why is it already running?
Robert,
Yes.
when you say Puppet is exporting resources to PuppetDB, you mean the agent or host creates a definition for himself, and then the master, where the zones are defined, actually imports its definition, sort of like a self-discovery mechanism if the node is defined in Puppet?
Can you please repeat this?
Yeah, when you say you export the configuration of an agent, I understood that the agent or would-be agent actually creates a host service config file for himself, but instead of applying it locally, it goes to PuppetDB.
Yes.
And then when Puppet Master actually runs Puppet, it realizes I have these exported resources and incorporates them into the files?
No. This is a Puppet concept. You have the Puppet server and the Puppet DB. When the Puppet agent talks to the Puppet server, it gets the code which it has to apply, and there are these special resources which are marked with the @ sign. These are in the report which the Puppet agent sends back to the Puppet server, and the Puppet server knows, okay, I saved this in the database. Next time when the Puppet agent on the Icinga main server runs, it looks into the database and searches for everything which is tagged with Icinga host, Icinga endpoint, or Icinga zone, and then imports it directly from the Puppet DB without talking to the Puppet server.
Okay, so it's basically an auto-discovery mechanism via Puppet, right? I, as a host, create myself, push to PuppetDB these resources, and then the master carries it and applies?
Can what?
The master actually checks PuppetDB and applies these new objects from the host, right?
The Puppet agent runs every 30 minutes on the Icinga main server and then imports everything which is new or changed. As we have seen, we have now run Puppet in the background here. We have systemctl status Icinga 2 running here. When we switch to the web interface, we see nothing here because the Icinga server, the Icinga main server, has not run Puppet yet. So we switch back to Visual Studio Code, go to the Puppet server. No, sorry, messed up, to the Icinga server. And as you have seen, the does not know of the configuration yet. So I run Puppet on the Icinga server, and then it will import the exported resources from the Icinga agent. As you can see, here is coming in some data from the Icinga agent 1. Here's a zone, and here's a host endpoint, and down here somewhere is a host. So the exported resources have worked, and now I see here when I go to host, I have an agent 2 host, and it has some services running, and it has some checks automatically assigned. So I can set up a Icinga server, web interface, and some agents with Puppet, with some Hiera data, and can roll this out without clicking in any UI or doing anything else, just working in my Puppet code, or even better, only in my Hiera data. There's one, how do you say this in English, caveat? Some problem with the exported resources. The more you have, the slower the Puppet apply goes. So, for example, you saw the Puppet runs was really fast. This was working, but now I will simulate a little bit bigger setup of hosts on the Puppet server. I will include a new class. It's called load test. And I will go to the load test. It will iterate over an integer from 0 to 900 and export some host objects into the PuppetDB. So I go to my Puppet server for a moment, Vagrant SSH Puppet. And it will now apply the load test class. So in the end, nothing will apply it on the Puppet server itself, because it will only just export 900 resources. So this was quite fast. Let's see how fast we can go to import this again, if I did this right. I will set a time before. And then we should see that this will take a little longer than expected from our past Puppet runs. Because now it's compiling the catalog on the Puppet server. And when we go to the Puppet server and try to htop here, we will see that there's something going on. The Puppet server process is doing some heavy stuff. And over here, the agent is waiting for its Puppet code to get. And the more exported resources you have, the longer this takes. With these 900 resources, the catalog compilation is around 30 seconds or something, which is quite long. Normally you have some 10 seconds around. And now the catalog is applied, and this will take another like 1 minute. So that's the one problem with the exported resources, because they are really slow. Yeah, and that's all I wanted to show.
How many hosts did you just
900.
deploy? 900? All right, that's quite a lot. Do we have any questions for Robert? Over there.
Not really the question, but first thanks for using the module, or the several modules. But please, for your future, have a look at the classes Icinga server, Icinga DB, and Icinga IDO from the module called Icinga. There, most stuff you do by hand is integrated in these classes.
This valuable information was, by the way, provided by the maintainer of this Puppet modules. He's sitting over there.
Big thanks to Leonard.
Thank you, Leonard. Do we have anything more left?
Thanks. Hi. I would like to know how are you getting rid of hosts that don't exist anymore in a setup like this?
When a host is destroyed, it also is revoked and cleaned up from the Puppet DB. And when it's not in a Puppet DB anymore, it will automatically be removed, because then the collector sees, okay, I have a host file which is not in the collector again, and then I remove it. So everything is bound to Puppet. Puppet DB is the main connection point between the main server and all the agents. If some new host exports it into the Puppet DB, it will get applied on the Icinga main server. If it is destroyed and cleaned up in the Puppet infrastructure, its data in the Puppet DB is removed, and so it will be removed on the Icinga main server on the next run.
Awesome. Thank you very much, Robert, for these insights.
Thank you.